A long time ago on a warm summer's day, Napi, the world's greatest trickster and a folk hero for the Blackfoot tribe that inhabits modern-day Montana and Alberta, was traveling northwards with his friend Coyote. Napi had just cheated someone out of a very nice buffalo robe, and the sun and the wind thought that they would give him a taste of his own medicine and play a trick on him. The sun shone very brightly, making Napa hot and sweaty and the robe heavier. When the robe got too heavy, Napa asked Coyote what he should do with it. "Why don't you give it to that big rock over there?" said Coyote. Napi thought that it was a good idea, so he went over to the rock, praised the rock, and then gave the rock the robe as a gift. No sooner had Napi and Coyote headed off when the wind started to pick up, blowing very cold air. Napi began to think that he should have kept the robe. He told Coyote to run back and get the robe from the rock, but Coyote didn't want to. Napi goes back and tells the rock that he would like his robe back, to which the rock replies, "But you gave it to me." Napi responds, saying, "What are you going to do with it anyway? You're just a rock." So Napi takes the robe from the rock and heads off with Coyote, reluctantly by his side. All of a sudden, Coyote hears a big noise and looks back to see the rock rolling after them. Coyote and Napi are quite startled and they start to run away from the rock. Napi and Coyote ran past the rest of the animals that Napi had played tricks on. Napi asked the animals for help, to which the animals, amused to see Napi finally get a taste of his own medicine, refused to help. Coyote realizes that the rock is only after Napi, so he runs away from Napi. Napi runs along the prairies, coulees, and rivers, staying just ahead of the rolling rock. Napi is soon very tired, and so some birds decide to take pity on him and help him out. The birds swoop down and start pecking at the rock, breaking tiny bits of it off. After a while of this, one bird dealt a final blow and the rock was split in two. This tale from the Blackfoot tribe describes the process by which a rock, creatively named Big Rock, made its way to the middle of the Canadian prairies, far away from any naturally occurring rock formations like it. These kinds of out-of-place rocks are called erratics, and they can be found all over the world, and until the 1800s, humans had no clue how they got there. Jean-Pierre Paudin was studying these types of rocks in his native Switzerland when he theorized that glaciers were the only thing that could produce significant enough force to move the boulders from high up in the mountains to the low valleys where they sit today. The only issue was that these erratics were found in areas that were way too warm to have possibly formed glaciers. This led to his hypothesis being widely discredited. It wasn't until 1837 that influential scientist Louis Agassiz came out in support of the theorem after he traveled to the Alps and determined that at some point in the past, glaciers must have covered the entirety of northern Europe due to the commonality of these types of rock formations throughout the area. He dubbed this period in history the Ice Age. By the late 1800s, the Ice Age theory was widely accepted after physicist Eunice Newton Foote proved that water vapor and carbon dioxide could trap infrared radiation when she created an experiment where two different glass tubes were exposed to sunlight and found that in an atmosphere of carbon dioxide, temperatures would rise much faster than in an atmosphere of normal air. She then theorized that if in the past the Earth had less carbon dioxide in its atmosphere, the temperatures could be much colder, causing an ice age. Thanks to all of the research done by 19th century climate scientists, by the 20th century, we knew that past glacial events were caused by a decrease in atmospheric CO2, but that then begs the question, what caused a change in the CO2 levels of the atmosphere? To find the answer to that question, scientists first needed to find a way to accurately track the temperatures of the Earth going back hundreds of thousands of years, which can easily be done through analysis of glacial and deep-sea cores. Doing this, we can produce a graph that shows us what the Earth's temperature has been like over the past 800,000 years. As we can see, the Earth goes through cycles where for roughly 90,000 years, the Earth is much colder, called a glacial period, and for 10,000 years, the Earth is much warmer, called an interglacial period. These cycles of warming and cooling line up perfectly with measured amounts of CO2 found in the atmosphere, which can also be determined by deep-sea cores and ice cores. But this still doesn't answer the question of where all the extra CO2 is coming from to cause the interglacial periods in the first place. Also, interestingly, if you look at the graph, it would appear that temperatures start rising before CO2 starts to increase. Well, as it turns out, the issue of the Earth's heating before the CO2 is released and the issue of where all the CO2 comes from can be answered with the same concept. Milankovitch cycles deal with three main concepts of the Earth's orbital mechanics, but only one of them is important when talking about the 100,000-year climate cycles. Obliquity is the tilt of the Earth's axis, and it varies from 22.1 degrees to 24.5 degrees over a period of 41,000 years due to the gravitational influence of other planets. Currently, Earth's obliquity is decreasing and peaked around 8,700 BCE. The main effect of high obliquity is that the amount of sunlight that reaches higher latitudes varies more than when obliquity is low. This causes warmer summers and colder winters. When obliquity is decreasing like it is now, we should expect to see milder seasons and more glaciation, as there is less time in the summer for glaciers at higher latitudes to melt, causing a larger buildup of ice. The obliquity of the planet itself doesn't cause the Earth to cool. The Earth still receives the same amount of solar energy regardless of its obliquity, but the important thing to know is that when obliquity is low, there are more glaciers. And that's relevant because glaciers have a higher albedo than any other natural formation on Earth, meaning that they reflect more sunlight than anything else. Conversely, exposed rock that is left in the wake of a melting glacier has a very low albedo, meaning they absorb more sunlight than they reflect. This in turn makes the poles warmer, melting even more glaciers, making more sunlight be absorbed in a runaway effect that causes most of the ice that formed in a glaciation period to melt. But the extra sunlight absorbed can only do so much, and the main cause of the end of a glaciation period is, as before stated, the release of the carbon dioxide. But where is this carbon dioxide stored? Well, I'll tell you where the carbon dioxide is stored. It is stored in the oceans. The initial heating of the Earth, caused by a decrease in its albedo due to the melting glaciers, causes CO2 stored in the ocean to be released into the atmosphere because warm water can't hold on to gases as well as cold water can, because the molecules in warm water move faster, making it easier for gases to escape. This starts a much more important runaway greenhouse effect where more CO2 is released, meaning warmer oceans, meaning more CO2 is released. The amount of carbon dioxide in oceans today is roughly half it was during the last ice age. This was a lot of information in a short amount of time, but what you should really be taking away from this is that we know that naturally the climate can change over long periods of time due to a lot of interconnected factors. And for most of the Earth's history, glaciation was the norm and interglaciation is the exception. And since we are currently at the end of an interglaciation period right now, we should expect to see cooler temperatures over time, but we're not, which I will explain in the next section. As stated in the previous section, we know that global temperature trends from the past 8,000 years due to the analysis of deep-sea sediments and glacial ice cores give us a good indication of what the global temperature should be doing, but we have even better and more accurate data thanks to As it turns out, in between conquering India and getting China addicted to opium, the British East India Company had a lot of time to take thousands upon thousands of temperature measurements from around the world, leaving us with incredibly accurate data about global temperature trends from the past 3 centuries. As you can see from this graph, since the 1800s, the Earth has warmed by roughly 1 degree centigrade. And if you look a bit further back, you can see that before the 1800s, global temperature trends were decreasing as to be expected when the Earth is coming out of an interglacial period. But something important was going on in the late 1800s that can give us a good idea of what caused this heating. The Industrial Revolution, which was being powered by coal, a carbon-rich fuel source that released carbon dioxide into the atmosphere when burnt. Also around the late 1800s, Peter Kropotkin was documenting that the Siberian glaciers had started getting noticeably smaller when over the past few hundred years they had been tending to get bigger. A third vaguely related thing happening in the late 1800s was Samuel Pierpont Langley researching the surface temperature of the moon. This last thing might not seem related, but it is important because through his observations of infrared radiation given off by the moon, Langley found that when the moon was lower in the sky, the temperature readings were much lower than when the moon was higher in the sky. This was to be expected by scientists as they had already known about carbon dioxide's infrared absorption for decades, but these measurements from Langley's studies would allow scientist Svante Arrhenius to calculate what changing the amount of CO2 in the atmosphere would do. His calculations show that if you have the amount of CO2 in the atmosphere, temperatures would decrease by 5 to 6 degrees. Other scientists around the turn of the century could use this math to estimate the effect of man-made emissions, which showed that at the rate of industrial output during the late 1800s, it would take roughly 1,000 years for the Earth to see any real effects on its climate due to human activity. Unfortunately, the scientist that developed this theory, Arvid Homburg, would be very wrong as human CO2 output was about to increase dramatically due to the Second Industrial Revolution, which started in 1870 and would end in 1914 at the start of the First World War. The Second Industrial Revolution saw the invention of cars, trains, airplanes, telegraphs, ocean liners. The list of CO2 producing machinery from this era is nearly endless. And another crucial development from the Second Industrial Revolution is that oil started to become a common fuel source, leading to even more CO2 being pumped into the atmosphere. In between the First World War and the end of the Second World War, there wasn't much research being done on climate change, as around this time scientists still thought that it would take thousands of years for the Earth to start warming. But an important argument resurfaced around this time about whether or not the warming of the Earth had been caused by CO2 output or extra energy given off by the sun. At this point in history, data was inconclusive on the matter, since records from the 1700s showed that there was a slight increase in solar radiation reaching the Earth from the sun, and it was still unknown whether or not this could be affecting temperature. Nowadays, the idea of the sun causing the increased temperature on Earth is widely discredited, as measurements from satellites show that solar energy peaked in the 1950s, and we are at a relative low point in energy being received from the sun right now. Starting back up in the 1950s, more research was being done on the production of CO2, and it was found by scientist Hans Suess that CO2 was being absorbed into the oceans at a much slower rate than previously thought, due to the warmer temperatures around its surface. This means that oceanic acidification, which was only starting to become a problem, would only get worse as time continued, even if all greenhouse production stopped immediately. In the 60s, statistics on how much CO2 was being released into the atmosphere were also getting much more accurate, and scientists began to fear that if little action was taken to prevent further CO2 emissions, the negative effects of climate change could happen sooner than previously predicted. This idea started to gain major attention when fossil fuel corporations in the 70s hired climate scientists to study the effects fossil fuels were having on the environment. They found that if nothing was done at current rates, by the year 2000, a change in temperature of 0.6 degrees Celsius was to be expected. The studies done in the 70s once and for all proved that the Earth's climate was warming, and that it was caused by human activity. Fossil fuel companies like Exxon, Chevron, Mobil, and Texaco decided, instead of warning the public about the imminent climate crisis and reforming their companies to produce green alternatives, they would start the largest disinformation campaign the world has ever seen. Unfortunately, during the late 70s and early 80s, America, the largest producer of greenhouse gases, shifted to have a more conservative economic structure, meaning less government interventions with the fossil fuel companies that were slowly destroying the world. A notable example of this is how the Reagan administration dismissed the threat of chlorofluorocarbons to appease industrial lobbyists, despite CFCs being around 1,000 times more efficient at absorbing heat than carbon dioxide. Before Reagan took office, most CFC producers were working on alternatives that would be less environmentally destructive. But after the Reagan administration took office, most of those projects were halted and CFC production rose significantly. The production of CFCs stopped only after scientist Joe Farman discovered a hole in the ozone layer that was directly caused by CFCs in the atmosphere. To address this issue, the United Nations drafted the Montreal Protocol, which was ratified by 197 nations, making it the first treaty in human history to be universally ratified by every nation on Earth. Today, climate scientists project that the ozone layer won't return to normal until the 2050s.
But the media men beg to differ, judging by the hole in the satellite picture.
Despite what these people will tell you, man-made climate change is not up for debate. It is a scientific fact that the Earth is warming when it should be getting colder, and that human production of greenhouse gases is causing this warming. Despite the overwhelming evidence that supports the theory of man-made climate change, disinformation is spreading faster than it ever has before. Today, the vast majority of Americans think that we need to do more to protect the climate. However, there is a very loud minority in American discourse that wants to spread disinformation about climate change for their own personal agenda. I would like to briefly talk about one of them and highlight why the things they say are not only incredibly stupid but also harmful to many Americans who are threatened by the planet warming. There are plenty of think tanks out there funded by fossil fuel companies that spread disinformation, but the one that is easily the funniest to make fun of is Dennis Prager's PragerU. He runs a conservative think tank that stands for Judeo-Christian values, but is actually just a front company for the Koch brothers to stop public discourse on their contribution to the destruction of our own planet. One of their worst videos that they have put out is one entitled, "Climate Change, What Do Scientists Say?" Instead of being anything remotely educational, the video relies on a cropped graph of global temperature changes, claiming that the Earth is actually getting cooler. First off, the graph is measured from the year 1997, which saw a massive spike in global temperatures, making it appear as though temperatures have stayed the same or slightly cooled since 1997, when actually, if you include data before their arbitrary cutoff, the graph shows that the Earth has warmed significantly. If you include the rest of the data, long-term there is no indication that climate change is slowing down, nor is there any mechanism that has been discovered that could slow down climate change, as emissions have only been increasing since the 90s. The video then goes on to show that the discussion of climate change is a highly debated topic within the climate scientist community, which it isn't. Recent polls show that 97% of active scientists have published papers agreeing that climate change is man-made. The papers published by these scientists aren't opinion pieces. They are actual research papers describing experiments that these people did to prove the theory of man-made climate change. This video also states that CO2 isn't the primary cause of climate change. I already explained how CO2 is the primary cause of climate change earlier in the video, so if you need an update, you can just rewind it. Then this video goes on to state that temperatures have only increased slightly since the Industrial Revolution, which is either willfully ignorant or maliciously deceptive, because an increase of 1 degree Celsius over the span of 200 years is faster than any natural process could ever manage. This video also claims that people push the idea of climate change just so they can make money, which is ironic as the presenter in this video is getting paid to spread lies on behalf of a fossil fuel company, so that said fossil fuel company can continue the destruction of the earth for short-term profits. The evidence presented in this video is so laughably inefficient to disprove the argument in support of man-made climate change that it would be quickly called out on its many fallacies if it were presented anywhere outside of the echo chamber of lies Dennis Prager has created. The reason that think tanks like this can thrive is mainly due to their corporate backers. The coal, oil, and auto industries have a vested interest in continued use of fossil fuels, so they pay billions of dollars to politicians and think tanks like PragerU, also that they can do long-term damage to the planet for short-term gains of wealth, benefiting only the richest people in the world, while millions are starting to suffer from droughts, famines, and coastal flooding. The future effects of climate change really depend on if we decide to do something about CO2 emissions or not. It's very possible that within the next 5 years we develop a technology that's able to sequester carbon dioxide fast enough to prevent the fallout of climate change altogether, or we could just decide to go full ecocide, cut down every forest on Earth, and pump so much CO2 into the atmosphere the planet becomes a hellscape. Since it's impossible to predict the future with 100% accuracy, I'm going to briefly discuss what we know for sure will happen if our current rate of CO2 emissions continues. First of all, obviously it's going to get a lot hotter in most regions, but in temperate climates it won't get hot enough to cause massive problems outside of the runaway effects a hotter Earth causes. The bigger issue that climate change is going to cause is that the Earth will get drier. The carbon dioxide that we're currently releasing into the atmosphere was sequestered roughly 55 million years ago during a massive bloom of Azolla, an aquatic fern that is estimated to have sequestered tens of trillions of tons of CO2. Before the Azolla bloom, the entirety of the Earth was covered in rainforests, with tropical plants being found in Siberia and Antarctica. At this point in Earth's history, atmospheric CO2 levels were roughly twice what they are today and 3 times what they were before the Industrial Revolution. The reason the whole Earth was a tropical rainforest at this time is because a warmer atmosphere contains more water vapor, making rain more common. Rainforests themselves also tend to fuel their own expansion due to a process called evapotranspiration, where they suck up groundwater and expel it into the atmosphere, making rain more common. This can be seen through these satellite images of the Amazon rainforest. Notice how the patterns of clouds indicate that the clouds are forming just above the rainforest due to the extra water vapor produced by plants through evapotranspiration. So if the Earth is already covered partially in rainforests, we should expect more rain in and around them, causing the Earth to get much wetter. But the only problem is there are hardly any rainforests on Earth. The largest land climate that can be found on the Earth today is deserts, and the exact opposite thing happens to them when the Earth warms. Deserts and the areas surrounding them get drier. Looking at this map, you can see a prediction of the change in annual rainfall that we should expect in the next century. And with few exceptions, areas that are wet are going to get wetter and areas that are dry are going to get drier. Some very noticeable exceptions are the Amazon rainforest, which will only get drier because of decreased evapotranspiration caused by deforestation in the region. Another exception to the rule are the Arctic and Antarctic, which are both some of the driest places on the planet. The only reason that the polar regions are as dry as they are is because the air there is too cold to hold onto any water vapor, meaning that the slight rise in polar temperatures will cause extra rain to fall. But for the most part, places like the Mediterranean, the southwestern United States, Australia, and the Atacama Desert will see less rainfall, and areas like Southeast Asia, the northeastern United States, and India will see more rain. Interestingly, the Sahara Desert and the Arabian Peninsula will see an increase in rainfall due to the expansion of the Indian Ocean monsoons, which I will explain in the next segment. You might have noticed that 2020 had a particularly bad hurricane season. Well, believe it or not, this is actually caused by warmer ocean temperatures as a result of man-made climate change. This is because evaporation fuels hurricanes. The mechanisms that cause hurricanes to disperse over land is the same one that causes them to get much larger when they're over the warm Caribbean Sea. In short, warmer ocean waters makes hurricanes more frequent and much worse. The same thing will happen in Southeast Asia and India as the monsoon seasons continue to get worse and worse, and even some remnants of the Indian monsoons will start to reach the Arabian Peninsula and the Saharan Desert. The remnants of the monsoon that will be reaching Arabia don't add up to much though, and only amount to a 60% increase in rain, which in this desert climate won't change much over the span of 100 years. The larger Indian monsoons will bring bigger waves to the shores of Arabia, causing coastal erosion. Hey, speaking of coastal erosion, This is the big one that everybody talks about. Most people have probably seen the map that National Geographic has put out about rising sea levels destroying the world. And if you haven't, well, now you have. An often used counter-argument against rising sea levels destroying coastal cities is that a lot of the Arctic's ice has melted and we have seen very little sea level rise. This argument isn't based 100% on facts, as Arctic sea ice actually displaces about the same amount of water as the melting glaciers will fill in. So we're actually at the very beginning of sea level increasing as glaciers in Greenland and Antarctica start to melt, adding more water into the Earth's oceans. Another big reason for the sea level rise is coastal erosion caused by the aforementioned larger storms warm waters will create. In more developed nations, this can be combated by depositing deep-sea sediments onto our beaches, but this is mainly only done in tourist hotspots, is destructive to the deep-sea ecosystems, and is very costly. Europe is warm. It is much warmer than it should be. England is roughly at the same latitude as northern Quebec and has a similar climate to New York. This is because of the Gulf Stream, and no surprises, climate change is messing that up too. The Gulf Stream happens because hot water is less dense than cold water, so hot water from the Caribbean flows in to replace the cold water in the Arctic sinking to lower parts in the ocean, making an ocean gyre in the North Atlantic where warm water is carried to northern Europe from the Caribbean. The thing that's threatening the Gulf Stream right now is Greenland's melting glaciers. Temperature isn't the only thing that affects ocean water density, salinity also affects it. When fresh water enters the ocean from melting glaciers in the Arctic, as water around the Arctic becomes less dense, hot salty Caribbean ocean water isn't able to replace it due to them being the same density. If the Gulf Stream is destroyed completely, as some climate scientists believe is inevitable, Europe will have a climate of that similar to eastern Siberia or northern Canada. America is a fully developed nation with a population pyramid that shows that it has a stable population and has a good position for its future as the population is slowly growing and there is no imminent threat of a worker shortage anytime soon. However, Alaska has an issue where there are more working-age people than there are children, suggesting that it'll soon be facing a population crisis similar to the one that Japan is facing right now, where there aren't enough young people to take care of the older generation. This isn't the case for Alaska though, because a large proportion of its working population are imported from other states to help local industries in the far north. Either way, taking care of an aging population wouldn't be an issue for Alaska, as the federal government is responsible for elderly care through Social Security and Medicare. The city of Shishmaref itself is facing a crisis of both melting ice disrupting their food sources and the rising sea levels that threaten many people around the globe. It sits on a low-lying island, and so far the coastline has already advanced upon the small town, taking away a few houses. Storms have slowly been eroding away the coastline, causing a small-scale migration further away from the coast within the island. Another issue is food. The people who inhabit this town are mostly native Alaskans, and they rely on the sea ice to be able to travel out to the waters for fish and seal hunting. Every year, the ice freezes later and later, leading to higher dependency on imported food, and as it stands right now, the people are starting to migrate off the island as they know their time is limited. The village is currently working on moving to the mainland, but they lack funding from the federal and state government. The government has a responsibility to foot the bill for this town's relocation, as their laissez-faire economic policies and lack of regard for science has caused this crisis the village is now experiencing. These people deserve the same rights as all Americans and should be guaranteed life, liberty, and the pursuit of happiness on their own land, the land that their people have inhabited for 100 years, the land that is disappearing because of man-made climate change. If the federal government can subsidize the coastline recovery of a major tourist hub in Florida, then it is obligated to do the same for the people that it has stolen land from, pushed onto reservations, and forced into poverty. In conclusion, we should probably start taking climate change seriously.